So good afternoon, everybody, and welcome to our webinar, Achieving Net Zero in the Construction Industry. If I could just ask you to switch off your cameras and mute yourselves, we'll get going in a moment, and there'll be an opportunity to ask questions as we go through, either by putting the questions directly into the text or unmuting yourself in the Q&A session and raising your question. So I'll just get going in a second. I'm just lining up my slides. There we go. So my name is John O'Brien, and I'd like to welcome you to our July webinar. We've got two great guests today. We've got Stewart Dalgarno from the Stuart Milne Group and Adetunji Lawal from the Align JV. And just to give a quick intro, and I'll pass to my colleague Mike and Stuart and Adi shortly, and they'll say a little bit more about their roles. But Stewart Dalgarno is a project director working in advanced industrial methods of construction for homes. And Stuart Milne Group are one of the UK's leading independent house builders. And Stuart's role is as Innovation and Sustainability Director, and he focuses on the introduction of new products and processes such as modern methods of construction, BIM, building information management and standardization within the homes, looking to deliver electric integrated homes, community cars, homes without gas, and is also responsible for the governance of the group's sustainability strategy. And Stuart will say a little bit today about how the housing sector is shifting to net zero carbon. Adetunji Lawal is the Carbon and Energy Manger for Align JV, and his focus is on delivering complex tunnelling and viaduct construction projects. He's a particular interest in building automation, alternate energy systems, net zero transition, renewable power and heat pumps. And he'll say a little bit today about the pathway and challenges to net zero construction on major projects. So my name is John O'Brien. I'm the MD and founder of LCMB, for those of you who haven't met me. And Mike Kenny, my colleague, who's the managing consultant of our energy, carbon and net zero carbon team, will be chairing today's discussion. Just to say a little bit about LCMB, our focus is on transforming the impact of our clients' workplaces, buildings and estates. And part of that is helping our clients with the transition to net zero carbon. So the objective for today is to share insights from our guests and Mike and tips for your route to achieving net zero carbon in construction, the construction and management and operation of built assets. So as a business, I guess we've been working with the UK GBC framework for delivering net zero carbon built assets over the last decade or so. Mike will say a little bit more about our recent work, but we've been involved in looking at both embodied carbon and operational carbon through the delivery of new built assets, refreshing existing built assets, as well as delivering net zero carbon strategies for scope 1, 2 and 3 across large complex buildings and estates. So we've touched both the sort of new build, the operational side of built assets, but we're really interested to hear from both Stuart and Adi today as to their insights from the construction of, I guess, built assets at either end of the spectrum. Adi's involved in major projects and infrastructure, and Stuart's involved in delivering sustainable net zero carbon houses. So I'm going to pass to Mike, who will introduce himself and the guests and take us through the discussion for today. So over to you, Mike.
Hello. Yeah, thanks for joining us today. Just to introduce myself, I'm managing consultant here at LCMB. So I focus on the energy and carbon and net zero side of things, working with lots of different clients, higher education, NHS, commercial sector. Net zero has all become very topical and there's a lot of demand for it. And given the public sector decarbonisation scheme, even more incentive for people to decarbonise. So I'd like to welcome Stuart and Adi, our two speakers for today. And if we could start with Stuart, if you could just tell us a little bit more about yourself and your presentation. You're on mute there, but we can see this. We can see the presentation.
Okay, so is that better now? Can you hear me better? Mike?
Yeah, we can all hear you. That's great.
Okay, perfect. Right, welcome everybody. My name's Stewart Dalgarno. I'm the Director of Innovation Sustainability at Stuart Milne Group. We're a dedicated house builder. I'm also the Project Director for a large-scale UK flagship housing innovation project called AIMCH, which stands for Advanced Industrialised Methods for the Construction of Homes. This project is now complete. There is a website, which I'll come to at the end, where a lot of content is available for you to see and get good insight into. It's a Innovate UK funded project, £6.5 million with a £4 million grant for industry partners, Stuart Milne, Barratt, London and Quadrant, three of the UK's premier house builders, London Quadrant from a housing association point of view, Barratt from a private development large scale, and Stuart Milne from a smaller SME developer perspective, two research partners, Innovation Centre and MTC, and Foster Roofing, who are an SME subcontractor. So the ambition of the project was to scale up the use of panelised MMC systems using industrialised techniques as we transition towards net zero carbon homes. Our focus has been on digital working and standardisation, including things like design for manufacturing assembly to maximise and optimise the use of MMC. Our focus has been on panelised MMC systems, so not volumetric or modular that some people might be using. We've also looked at the manufacturing of those systems and developed some of the world's fastest and most advanced production lines, which we'll show you in a minute. And we've built homes to current regs, enhanced regs, and net zero carbon concept homes for both suitable for both the private development market and the affordable market. So as part of this project, our achievements have been to effectively build a net zero carbon home. We believe the first, called the Z House, by Barratt with Salford University. I'll talk more about it in a minute. We've developed low carbon manufacturing systems, including full scale robotics for the production of panelised MMC systems at scale. We've also developed digital twin factories for net zero carbon factories to produce additional capacity to service the demand for MMC systems. And we've also done a little bit of work on embodied carbon, looking at the benefits of timber panelised MMC systems versus brick and block constructed homes. Our focus has been on low-rise housing, and our focus has been on a fabric-first approach, a sort of fit and forget solution to building a high-performance, low-energy fabric that drives the energy performance of the heating system down, and then decarbonisation after that. We've used techniques which are scalable and viable, so we're within 3% the cost base of masonry, which is quite a good price point to be at. And some of the images you're seeing on screen there are some of the technologies we've used. So for example, a closed panel, timber frame, fully insulated, sealed, windows pre-fitted, floor cassettes pre-manufactured up to 12 metres long by 3 metres wide, prefabricated party wall panels with the fire protection pre-fitted. Image in the bottom right, effectively a house built without scaffolding, using an edge protection system. And the house on the bottom left is a fully tiled roof built on the ground, lifted on. So that house there is at Barratt's development in Warrington. So fully insulated to about a 0.15 U value, air tightness of 3, windows pre-fitted, plasterboard loaded in, floor cassettes on, roof on, no scaffolding, fully tiled in just under 7 hours. So allows then the contractor to effectively finish off the cladding by putting a brick veneer up the outside, a traditional cavity, or lightweight cladding if they wish, and fit out the remainder inside in terms of the first fix setting work, fix works. We've also looked at prefabricated foundations and modular roof systems. all of which have been monitored and trialled through actually having full-time research students on site doing time and motion studies. And that's given us the data to make really informed business cases. The thing that's maybe most interesting to you is effectively the first net zero carbon home, which is known as a Z House. This was at Salford University with Barratt Homes. So the image on the left is one of their standard products. It's a Arderley house type. It's a common house type that Barratt Homes build. It's pretty much a vision of the future. It's an MMC fully produced home, panelised systems with a lightweight cladding on the top and a prefabricated brick veneer on the outside. Inside, we've got vehicle grid charging, we've got PV on the roof, we've got PV diverters to the cylinders, we've got air source heat pump, with storage, skirting, heating trunks, and we've got infrared heating. So it's pretty much full of the type of technologies that are going to be used in the future. And part of the project beyond this is to monitor that home and to have people living in it and to monitor. It's got a lot of sensors in that building and monitoring the performance of the home as we move to these kind of new technologies going forward, which are going to be our mainstream solutions for our transition to net zero carbon as a housing provider. In addition to that, we've looked at things like the manufacturing side of the MMC systems. So we've developed effectively digital twins using car technology to simulate future factories, which are efficient to manufacture and build. And the image on the left is a totally net zero carbon factory with a PV array on the roof, battery storage integrated, combined heat and power solution that will generate all the timber frame panels from that factory. It's a typical 5,000 unit factory, what's known as a hub, that is self-sufficient in its own energy consumption. The images on the right is the world's most advanced production line. That is actually currently committed and through Stuart Milne Timber Systems, now known as Donaldson's because it's been recently acquired. That production line is actually going into Whitney in Oxfordshire currently, and it will produce both closed and open panel panelised systems. It's got 9 robots on it, and it's got the world's fastest production head for filling insulation into wall panels. So taking, embracing kind of the car industry techniques that we've seen in images in the past, I'm sure, we find it difficult to get labour to work in these facilities. And, if we can automate things and use some of the BIM technology with standardisation and components, we could then deliver higher output in terms of producing product at pace and at low cost, which is kind of the key output. Couple of things to finish off with then. We've also developed a pattern book of net zero carbon ready homes. So through our sort of whole ethos of design standardisation, we've got a range of affordable homes, 18 homes in total, from a bungalow right through to cottage flats, which are compliant with the NDSS spatial standards, fabric ready to take a heat pump or can take a heat pump now, so they can be net zero carbon in the future. All crane friendly, panelised MMC friendly and optimised. And one example of that is the image on the left, which is essentially bathroom pods. So in the future, we could actually drop in a bathroom pod as part of the prefabrication element. So you might have remembered the first image on the slide was that shell being built in a day. If you imagine that shell being built in a day and that bathroom being dropped in, you've probably got 85% of the work content of the home completed off-site, being brought to site with a very smart way of building it on site. So the last thing we did was embodied carbon, just to assess transition towards low carbon materials. As a house builder, we're interested in this. We've always used timber frame for our systems, but not everybody does that. It's quite common to use brick and block. So the first 2 columns are the ones worth looking at. 216 tons of embodied CO2 compared to 221 for a typical detached home, 4-bed detached home using timber panelised systems versus brick and block. So a 5-ton saving for a typical 4-bed home. And if you're building 10,000 homes a year, such as Barratt's and such like, that's a significant contribution. You'll see the coloured graphs, actually the embodied carbon is all about in use, as you're probably aware. 80% of the embodied carbon is in use, about 14% is actually in the construction materials. So once you've solved the fabric, which going to timber is a good step in the right direction, then you'll start to look at decarbonisation of like concrete floor slabs, the brickwork cladding on the outside, and for example, the concrete tiles used on roof tiles. So we're already starting to look at solutions for that, got a couple of roof tile manufacturers who are using recycled products to make lightweight, low carbon roof tiling systems, for example, as a potential long-term solution to decarbonisation of concrete used in roof tiles for domestic dwellings as the next sort of challenge. That's it for my presentation. Very quick canter through it. If you want to see more information, I recommend you look at the website, amch.co.uk. There is a wealth of information and all the work packages the project delivered, and it's a good starting point for anybody who wants to know further, see any further information.
Brilliant, Stuart. Thanks very much.
Thank
for
you.
That. Really good. I think you've just shown us the future. I think it's exciting. If I could ask you to stop sharing, and if Adi could start, we'll hand straight over to you, Adi.
Okay. So good afternoon, Mike. Can you see my screen?
We can indeed. That's brilliant. Thanks very much.
Okay. So good afternoon, everyone. Just as an introduction, my name is Adetunji Lawal, Adi for short, first name. And my role is Energy and Carbon Manager, employed directly by Bouygues, but I work on the Align joint venture for HS2. Been in the industry as a chartered energy manager and carbon practitioner for a few decades, more than a decade. Yeah, feeling old already. It's been interesting, and I'm hoping I can just tell us a few of our challenges in this sort of major civils world, so we can appreciate some of it, and also some of the things we're doing to make a net zero carbon future a reality. Okay, so I'll just run quickly. Yeah, so I think just understanding carbon, because I know a lot of us are practitioners, but just trying to put a difference between what we call embodied carbon and operational carbon. It's two things. For us as in the non-domestic construction sector, the large focus is on embodied carbon, but we do all we can to ensure that the operational carbon in the lifetime of the building is quite key. Is reduced as much as possible, so that's all locked down. Embodied carbon is largely the materials, the manufacture on site of certain elements, transport, the construction bit, accommodation, waste. Just put some perspective, UK construction industry produced 11.4 million tons of CO2 in 2020, just been clarified in the last week. The interesting thing is the emissions increased by 45% between 1990 and 2019. However, between 2019 and 2020, there was an 11% drop. Now, I'm not too optimistic that drop is a real drop. It may have just been COVID. But when we look at some examples of two projects here, just to hone in on the embodied carbon aspect here. This is a major civils real project. It's an HS2 project which I work on, and our embodied carbon is 72% materials. That's our own construction carbon. In effect, the embodied aspect and all is also 72%, so it's huge. Construction and waste 22%, transport 6%. I've also taken a mixed-use development here. It's a development Spring Mills in the London area, which is a development of almost 400 students' accommodation and 93 hotel rooms all together in one. And again, you can see the materials, i.e. steel, concrete, is a bulk. Obviously, you've got site energy used during construction, waste, and transport still being significant, but again, it's the materials. Interestingly, that development, they did a 25-year look at both embodied and operational carbon to see what the impact was. And as you can see, the carbon performance without the embodied emissions is 985 kilograms of CO2 per square meter, looking 25 years ahead. Now, when you add on the embodied carbon, just on here, is 1,560 kilograms of CO2 per square meter. So you can see that the embodied carbon is really key It's something we can't wish away. So if we get that right, we're really on the path to net zero. Okay, so the weight with which the impact reduction that can be achieved by different means or technology levers is quite interesting. But I think it's just useful to see this chart where you can see this is the build stage, and from there on you can bring in behavioral change, measurement and monitoring, commissioning, and all of that, and you could realistically drop operational carbon. But embodied carbon, aside from a little bit of carbonation that happens to concrete, it's there. You're living with it for the remainder of the project life. So some big wins, things the way I have seen it. Design is key. Using the right materials, off-site manufacturing, designing for deconstruction, those are really key. Yeah, things like fuels come in, utility connections, HVAC, heat pumps, building fabric, but importantly, the embodied carbon, you make the most benefit at design stage. So designing, getting it right, optioneering under that, using as much low carbon materials as you can. So within that material mix, that's really huge. You got concrete. So we're building tunnels. We're on the Align project, we're constructing one of the longest, perhaps the longest rail tunnel in the UK and the longest viaduct. This is a picture from one of our tunnels, one of two, and concrete is real. As you can see, it's concrete everywhere, and it's going on for kilometers on end. But concrete, just put in perspective, globally, it's vital for highways, tunnels. The cement industry, which obviously is the backbone of concrete here, generates some 2.8 billion tons of CO2, about 8% of global man-made carbon. For us to get to that 1.5 degrees, really, emissions from cement production has got to drop by something like 16% by 2030. So that's a lot of work. The concrete and cement industry, I've got a roadmap, which I'm sharing here. It goes to 2050, tells us what it is they're going to do, and relative to 2018. Now, they will reduce transport, reduce low carbon, introduce low carbon cements, switch fuel, but technically, what we can see is there's a big hanger on carbon capture using storage. Now, that's a bit of a difficult one. We haven't got any viable plans going on capturing and storing carbon in significant volumes right now. So there's a lot of work to be done there. On Align, one thing we've done, just going back to design optimization, we've got the longest rail viaduct in the UK once this project is complete. And at design, we sat back and we thought, really, do we have to construct it the way it's always been done? Does the width of this viaduct have to remain the same all through? Maybe not. Do we have to use steel and concrete all through on both the foundations and on the barriers? No. So we looked at it differently, and we're actually using glass. We're using glass fiber rather than concrete on the walls of the viaduct. So all of that saved us 28%, and some 63,000 tons of CO2, and that's quite a lot just on the viaduct section of the project. So that's really looking at design. Do we have to build it the way it's always been built? No. If we just thought slightly differently, use a few materials differently here or there, will make a difference. The other big one is steel. Steel is quite key. Huge volumes of steel that has to go into major civils construction. Now, how do we cut down on steel? There's a lot been spoken about well, recycled steel, but really even recycling steel has got an impact to it. So what do we do? And I think, in my view, we've got to go back to nature and think, well, what can nature bring to us that can reduce this? And one of the things that have been looked at the minute, apart from trying to make the steels manufacturing much more, less energy intensive, is beginning to use things like basalt rebar. It's something that's just come up in the recently, a new innovation. And what that's trying to do is taking basalt as a material, making it into steel fibers, that width, and actually using it in concrete. That way, you're using a material that doesn't have to go through the massive furnace and steel manufacture process that current steel has to go through. So another thing that's on the plate as we stand. But technically, for the steel industry to contribute meaningfully to the 2% target, if we're looking at 2% here, it's got to go from approximately 1.5 tons of CO2 per ton of steel down to 0.5. So quite a lot to be done there. Part L is helping. Part L 2022, which we're all familiar with, I guess, aiming for a 7% reduction in operational carbon. That would help us as well, looking at the operational side. There's quite a few things, some few things there. Fabric values being dropped significantly, ventilation heat recovery being brought in, and PV really becoming key to achieving that that reduction we're after. And then, of course, the big one is, how do we decarbonize the grid? Because decarbonizing the grid means that every kilowatt hour of energy that goes into manufacturing our materials and helping in the process of construction is green. So the Hydrogen Association have come up with a road plan, which I think there's a lot still to be done, but critically, all that renewable energy that's been generated, one way to stream it down and ensure that it's useful and is stored is hydrogen, because then you can use renewable energy to generate hydrogen and transport that hydrogen. Batteries been spoken of. Batteries great, but the world at some point is going to run out of potentially of lithium, cobalt, and all the other rare earth metals required. So in construction, what are we doing? Still with a strong case for hydrogen hybrid plants. I think hybrid is quite key. A bit of hydrogen, in some cases, battery, and in some cases, traditional fuels. We're looking critically at sweepers, dual fuel sweepers, our tower lights being hydrogen powered, again, with battery backup, hydrogen hybrid generators here. And then also we're looking at piling rigs. That's an innovation that's just coming up with Skanska and Ulemco. I don't work for Skanska, but I think what they're doing is great. So some of the things we're looking at in the industry, there's a whole raft of things, but I'm sure some of this will come up in the questions. So thank you. And that's me for now.
Thanks, Adi. That was great. And yeah, it just makes you think. Construction has come such a long way in such a short space of time, where we used to think of steel, concrete, block and glass, and now we're using completely different materials, and they all have that carbon saving aspect, which is great, and that's how we're going to achieve the net zero in quite a short space of time. So I was just going to ask you a few questions and then maybe take some questions from the floor. If I could address this to Adi first. So what do you think is the biggest carbon reduction challenge facing the construction sector, and how do you think it can be overcome?
I think the biggest is concrete and steel, how we decarbonize them. There's a lot of post-century zero carbon concrete out there that's been spoken of, but you couldn't just build a highway or tunnel or viaduct on a whim of, oh, I think it's going to work. No, there have got to be design codes. This concrete has got to be tested over years in many cases. So whilst there's a lot of innovation coming up, there is still a time lag for to establish that confidence for the design team to say, yes, that material is great. It's worked for 3 months, but yes, if I build a tunnel with it, it will last for 100 years. So there is a bit of a lag, and I think that lag is perhaps the biggest issue. It will take a few years. Sometimes the cycle is like 5 to 10 years between concept innovation to that particular product actually being used in a large scale in a long-term civils construct.
Yeah,
So
concrete and steel.
yeah,
Again,
concrete
so-
and steel they're still the biggest ones in the
Stuart,
room.
you're not using any of those materials, and you're using the timber alternative. What do you think is the greatest challenge facing the industry?
Yeah, I think for us as house builders, it's more about the grid readiness. So, as we transition to zero gas, no boilers and gas by 2025, and we introduce EV charging, heat pumps, and we start exporting power from, solar on rooftops, the grid's got to be ready to receive and provide that additional power, because the load is 4 or 5 times higher on the grid than a dual fuel gas development would be. So, I think the next challenge is about electrification of homes and the integration of that with smart grids, grid balancing, storage, and optimization of peak demands, because the grid's not really capable of taking that, and without significant infrastructure costs, we need to come up with a solution. So I think from developers, we're beginning to see the next thing. We're beyond the fabric first, we're beyond PV now, we're beyond almost heat pumps, not quite there yet with heat pumps, but we're getting there. It's all about the community and how you plug them into the grid.
Yeah, absolutely. So you're both doing the same thing, but in different areas in the domestic and the non-domestic market. So with the modern methods of construction, do you see a crossover between those two markets?
Personally, I think from my point of view, the house builder, yes. I see there is opportunity to learn from both sectors. Probably more in a residential environment, if I'm being honest. But schools, accommodation, care homes, student accommodation, education facilities. So a lot we can learn from standardization, platform designs, common kit of parts. That kind of learning could be used into the housing sector. Each sector's got its own nuances, its standards, and its guidance. So you'll never get one size fits all. But I think the principles for the different sectors can be shared. And in our case, housing, it'll be as a set of standards that could be put there to have a standardised house platform. Every builder in the UK probably has its own nuances about how they want to build their homes, but in reality, they're very similar. So there's a lot of potential opportunity for standardisation. So that's certainly one thing I think you can learn across sectors.
Yeah. Another area is paying for all of this. Now, we're being kept very, very, very busy at the minute with our public sector clients and the public sector decarbonisation scheme. And it's nice to see that the government are putting their money where their mouth is and are giving grant funding to achieve net zero in that sector. And, £1 billion has been pledged already, but it's not in the domestic sector and it's not in the commercial sector. So do you have any similar sort of grant funding in the domestic sector, Stuart?
Not that I'm aware of, but what we've been trying to do, it's difficult for business to innovate whilst doing the day job as well and building houses sort of style and thinking to the future, and it's always risky. So we do need some form of government support to help us de-risk those things when you're building houses where technology maybe isn't quite proven yet, because you don't build a lot of prototype homes. Barrett's, the one at EMCH, is quite novel because mostly you build a home and actually somebody buys it and lives in it. So the sectors that we're looking at is the energy sector, so like Ofgem, SIF2 funding, where you've got the funding for the energy sector, because I think energy and housing is becoming far more integrated. So maybe we look beyond, our own sector for funding pots to help us do stuff. And that's certainly an area of opportunity we're looking at going forward. Innovate UK were very good with the Transforming Construction funding call that they got from government to help both the housing sector and the construction sector do that. But as far as I'm aware, there's no further funding coming from government for the next round of that call, which is disappointing.
Yeah, when it comes to funding huge projects like HS2, do we see a commitment there from the government going forward?
Yeah, I think the government is committed to H2 and big civils because we need them as a country. Our infrastructure is creaking a bit here and there. So if we don't start to do the right things now, 10, 20 years down the line, we'd have a lot of capacity issues and things falling apart. But generally, there isn't much government funding direct. What's what's happening more and more is all of the big construction firms, including HS2 as a big project, are putting together a lot of innovation pots here and there, which is helping to support a lot of these innovation projects, and it's run the pipe, creating a pipeline of things that can be adopted and to establish a more low carbon construction space in the future. So it's not a great amount of money, so to say, but it is something to help. I think on a larger sort of national scale, the government definitely needs to shell out a bit more on innovation and building prototypes of things, so that we can study them. Because if you don't have prototypes that can be studied over time by the right analyst, engineers, structural colleagues, it's not going to end up in the actual build in the future. It's not.
Yeah. Well, as we were talking earlier about, just wanted to go back to space heating for a minute. So we're trying to get rid of these gas-fired boilers. Gas is still a fossil fuel at the end of the day, and that's what we're trying to replace with electrification of heating. I mean, hydrogen is an option, but the air source heat pump market seems to be in advance of the hydrogen. Hydrogen could be blended into your gas supply and provide that. But what do you think is the sort of Betamax versus VHS at this stage? I mean, should we be committing to the heat pumps while we should be considering hydrogen on a long-term basis? What do you think, Stuart?
I think you need all solutions available to you, and I think the runner at the moment for the house building community will be probably a heat pump. Air source heat pump will probably ramp up as we come off gas and go into electricity for heating. But we need, potentially you do need hydrogen, and then you're going to reintroduce a hydrogen boiler back into business into your home in 20 years' time. But I think hydrogen's still some way off being viable and ready. So the only one that's looking near to market ready would be the heat pump sector. And certainly PV was in that boat maybe 10 years ago, Now it's pretty much a done deal. PV's there. I think if you can combine PV with storage in a viable way, so you can produce and consume at the same time, then you can reduce, the demand on your heat pumps, etc., to generate, electric heating. I mean, everything's going to be electric cooking, electric heating, electric hot water. So that's important if you can use the PV, because there's no point in generating power from the PV during the day if there's nobody in the house and you're just putting it back to the grid. You kind of want to self-consume it so that the owner of that property gets the benefit in terms of a reduced bill, and not just a decarbonised grid that they've paid for, effectively, which is what it currently is.
Yeah. And Adi, I suppose we're not going to be doing much space heating with the HS2 project, but have you considered it as a byproduct? So if you're breaking ground and tunneling, is there the potential to maybe use ground source heat pumps in buildings surrounding the area?
Yeah, actually, there's a lot of that going on along the route, where as we're piling up, we're creating piles. Some of them are being finished up with ground source heat pump ready pipes for the future. So it's all part of the legacy of the project. There's a lot of it going on. I think some of the issues are around this. It's probably around scale, because it just is trying to follow sort of a very rural part, and very often you don't find takers very close by. But where there are buildings, facilities, communities that can take, a lot of that is ongoing, and it will begin to be piped out once the tunnels and the rail line is all finished. Yeah, there's a lot of that going on. But I think overall with heat pumps, I think the heat pump industry needs to take a little step back and ask themselves the question, how do they deal with extremes? Because for some users, is that user experience? What happens when the temperature is -2? Is my heat pump actually going to provide the same? Is the COP going to hold up? Real life tests have shown that there's some don't hold up. So I think there's a little bit of redesign required in that industry as well.
Yeah, that side of the heat pumps, that's a difficult one, the distribution systems, whereas with Stuart, you're starting with a blank sheet and you can get the right insulation in there in the first place and the right U values.
Yeah, they reduced the demand in the first place, but I agree with what AD is saying. We're still very nervous about the transition to heat pump. You know, the capacity, the installers, the product. We build in Scotland, obviously get some cold days up there as well. So you do the really work and scale. But it's probably the most promising likely solution that we're going to adopt. But we need to work with government to make a realistic roadmap and timeline for when that's going to be. In Scotland at the moment, it's a little bit of they've made a statement to commit zero gas by 2025, and it's almost like a cliff edge. And you think it can't be a cliff edge, it's got to be a gradual, slowly slope going down and a ski slope coming back up again. So maybe a 10-year transition period as opposed to just a cliff edge when we, suddenly switch off gas and go with heat pump. Yeah. And, create all kinds of consumer issues and legacy comebacks that nobody wants.
Yeah, you're right. You're right. It's a difficult one. I'm going to ask my last question, and then take some questions from the floor if we've got any there. And finally, I just wanted to say, what would you recommend to our audience here today who are involved in construction to reduce the carbon footprints of their operations and the built assets they are producing? What would you recommend, Adi?
What I would recommend is first, the design has got to be right. The design stage is where you get the most benefits in being able to reduce carbon. So whilst Part L and the like are trying to reduce operational carbon massively, the embodied carbon is still huge. So you've got to look at design. Optioneering has got to be there, exploring every possible material that can be used as an alternative, looking down the supply chain to find value for carbon value. Sometimes it may be a little bit more expensive, but when you balance the carbon reduction and the against the cost, the slight cost increase, you'll find we are in a better place. So it's really design, having a really sort of fine-tuned look at every material we're using. Is there something out there that's better, less carbon? Yeah, and integrating it. That's key.
What about you, Stuart?
Well, as a house builder, we're into fabric first, fit and forget, technology blind, no moving parts, be there for 60 years, never let you down. So, building a better fabric, getting U values down so the heat load is less. And in our case, we prefer to use timber. We're a low-rise housing builder, maybe apartments 4-story below 11 meters. Is the way to go, because you're going to get an immediate benefit going to timber, and you're going to get a fabric first approach, which is good for the customer, that they don't have to worry about it. And then all the mechanical solutions, MVHR, heat pumps, PVs, batteries, they all come in the future, but they come with some form of maintenance. And our preference would be, or my suggestion to people would be, try and get something that's a maintenance-free passive solution first.
Yeah, indeed. I see that we've got a question from the floor from Scott Walker, and it's addressed to Adi. How prolific is the use of basalt fibre in rebar? On rebar, I think he means. Are you using it in your projects currently? You mentioned that on the viaduct, didn't you? Was that basalt?
No, it is new. It's too new for us to have to use it. So at the minute, it's still going through trials. So really, to answer the question, it's new in the UK. It's still going through a lot of design trials. It's not yet in the Eurocodes, which means you can't include it in a long-term projects that a structure that's going to stay for 120 years. But for some sort of temporary works structures, i.e. just a year or two for the duration of the actual construct, there is some integration already happening in the industry where consideration is being given to the use of this basalt fiber. But for main works, it's not yet found space. It will take a few years, I think, but it's one of the things we should be looking at for the future.
Scott, feel free to take yourself off mute and say anything. Oh, you've just typed. Yeah, he's just so that's great. Understood. Thank you very much. So today we've seen Boris leave number 10, and governments do tend to go round in sort of 5-year cycles. I think a lot of the net zero that we need to be looking at has to think of beyond the governmental cycle. Do you think that some governments are going to, the successive governments are going to put as much money and resources into achieving net zero?
I think so, because there is a commitment. Unfortunately, COVID and the the high cost of governance in that period, supporting communities and nations, it's been quite difficult. Yeah, the government probably hasn't had enough to play with in terms of funding for the industry, but it will happen. I think it will happen very soon. I think there will be more funding. Whoever comes in next, I think they're going to look at the commitments that have been made by the previous governments and want to make real those commitments.
I think, Mike, from my point of view as a house builder, we're driven predominantly by building regs, and we'll go wherever building regs goes. But I think there is a missed opportunity to create a market pool for low carbon homes, with low cost living being a key feature and off the back of the current crisis and the gas dependency and whatnot. So we feel the approach should be to try and drive value for these homes through the lenders and the mortgage peoples and the insurance community to give preferential mortgage, or to value a property higher than a second-hand home, because a new build home's got all these additional features and benefits, and they're getting quite significant now compared to a second-hand home market. And as a builder who sells, circa 1,000 houses a year, we find it difficult to get the price for what the opportunity is, because the mortgage people don't do it. So I think there's a bit of a push to me from government to lobby to create the value proposition and the market pool that people actually will pay for some of these things, because they see the long-term benefit, particularly in a house. It's maybe difficult in the type of projects that AD's involved with, but for us, it's not always about a regulatory drive. It's also about just creating a market opportunity, and businesses will step up and look for that and look to take that opportunity. And one of the constraints on that at the moment is valuation of these properties, which should, in my opinion, be significantly higher than what they are.
What percentage higher do you think they should be?
Well, if you put 5 to 10 grand on a house because it's zero carbon, it doesn't seem a lot to put onto your mortgage over 20 years, and within 3 to 5 years you'll have made your money back, and whoever buys the next property after that. So to me, why isn't that taken into consideration when valuation people are surveying homes, for example? Because that's kind of where we're at. 10 grand more for a home. Yeah, it sounds a lot, but to put it on your mortgage over 20 years, it's probably, you wouldn't even recognise it on your monthly mortgage. And you've actually got a home you're not exposed to bills on, because you're paying, I don't know, 50 quid a month rather than 250 quid a month.
Yeah. Brilliant. Okay, thanks very much, guys. Really appreciate that, and your knowledge and your time. I was just going to hand back to John to see if he want to say anything else. We're keen to finish this by 3 o'clock and stick to people's diaries commitments. So if I could hand back to John, that'd be great.
Okay, thank you, Mike. There's opportunity perhaps for a final burning question from the floor, but before we get that, I had a quick question for both Adi and Stuart, starting with Stuart, and just thinking about the sort of refurbishment angle of what you guys were presenting, because I guess in the UK, 1% of the built environment is refreshed every year. So it means, what's going to be standing in 2040 is predominantly there. So Stuart, from your point of view, where do you see the big opportunity to apply your sort of innovative and creative thinking for new build to the retrofit market?
I think the big benefit is in the retrofit market of homes, for sure. That's where you're going to decarbonise and get your savings, for sure. I'm not sure how much of the technologies is transferable into the retrofit market, because if you're doing a reclad in a building, that's quite a significant cost. It's a very difficult thing to do. If you're doing an internal insulation upgrade, that's a big thing to do. If you put a heat pump into a home, it's not particularly efficient because it was built 40 years ago, it's not really going to be a solution for you. It's the only thing it's kind of, is probably doable is some form of PV, which you see, quite commonplace now. But PV without storage isn't really getting the home user that benefit. But it is a big challenge. And I think the biggest challenge is really in the retrofit market. Us house builders, we're doing all right. We're actually doing a good job. We've significantly improved, and we'll continue to improve, and we'll get there with net zero. But as you say, if it's only 1 or 2 or 3% of the volume, is really the problems on the existing stock. And a lot more could be done on that, I believe. But it's not an easy one to crack.
Okay.
I think it's easy just to tell us builders what we need to do and drive us that way than it is to, repair 5 million homes or whatever it is.
And Adi, a similar question to you. I mean, you showed us that 72% of the sort of embodied carbon is in the material component of a construction project. So I guess if we're refurbing construction, what we need to do is ensure that we maintain as high a percentage of the materials, the original materials in the building, as we make it over. Do you agree with that? And do you see any opportunity to minimise lifetime energy through the refurb based on the work that you've been doing?
Yeah, I think there's a great opportunity to reduce through refurb. Obviously, you're not going to be refurbing tunnels or highways, but in the sort of space where we're doing hospitals, where we're doing schools, care homes, and some offices, there's always a big space there. And what I've found in the little refurbishment we've been involved in is we've always managed to take it a step further, because non-commercial refurbishment tend to be a little bit big on capex being laid out. So there's an opportunity to, in some cases, actually change the facade, improve the fabric in some cases for floors. So yeah, there is an opportunity there. And I think there is a big sort of national reduction opportunity there if we're advancing. Now, one thing the government could do to help that would be to legislate in a way. Currently, the minimum standards is a C, EPCC, for commercial lets. I think if the government made that a little bit tighter, probably closer to an A or B, then it will, open more of a floodgate for more renovations that are net zero minded.
Okay, well, thank you, Adi. So I'm just going to close this out because, as Mike said, it's just coming up to 3 o'clock and we want to wrap up on time. I want to say a big thank you to Stuart and Adi, who gave us some very thought-provoking presentations and answers to Mike's questions. Lots to take away and think about. So a big thank you to you guys for sharing your ideas, your insights and your presentations today. And hopefully those who joined us today found the discussion useful. It will be recorded and shared on social media, so it'll be available to share with your colleagues if you would like to do so. And if you found today's discussion and webinar of interest, go to our website and you can sign up for our newsletter, future tips from our clients and webinars. And there's a myriad of white papers and insights into both net zero carbon and optimizing built environment. So once again, thank you, Stuart. Thank you, Adi. And we're going to wrap up now and close out. So thank you, everybody.
Okay. Thank you.
Thank you, Adi.